Hello students, welcome to Unit 1 Notes, Section 1.4. Again, feel free to pause the video right now and try to do this warm-up on your own. When you are done, you can unpause it. And to save time, I will begin in a second or two explaining the warm-up. All right, so judging by appearance, will these lines intersect? I hope that you were able to put yes for this one. Oops, let's do a different color. Yes for this one. Looks like eventually when they go on, they will hit that intersection. These appear to be, this one appears to be a no. And the reason being is it looks like they are this thing that we call, remind me what it is, parallel, right? So I think the answer to this one is no, parallel. Okay. And then this one, it does look like they intersect, but think about that desk for a second, okay? Think about you have a pencil on the desk and it's pointing in a direction, and then you have maybe a hole in the desk where you were able to actually put thread through, and it is in no way going to interfere with that pencil. So these will actually not intersect because there is a depth to them. It's hard to see, but by appearance, but that is kind of what's happening for this one. Well, I'll leave those there. And so we're going to call this, we're going to say no, and we don't have a reason yet, but that is going to be part of our lesson today. So no, and once we know the word for what this is, because they're not parallel, they don't intersect. So they don't intersect, but they're not parallel, and there's a word for that. So we'll get to that in a little bit. All right, here for numbers 4, 5, 6, 7, 8, and 9, we have name the plane represented by each surface of the cube. So the bottom, we can call this plane NSM. That's just one of the answers. You might have something different. We also have the top, which is plane, we can name it plane PKL. Then we have the front, which we can name plane KLM. Remember there's many different, we could use 4 letters if we want. 3 is good for now. Then we have the back, which we can say is plane P, you know what, I'll do 4 letters. PQRS, I think it appears to be the back, so plane PQRS. Then we have the left side, which is plane PKN. And then the right side, plane QRM. I just want to make sure I got these all right because I kind of did them fast. So NSM. Yep. So for this one, you could have used NSM and R. Any 4 of those letters, any combination, NSM and R. For the top, any combination of the 4 letters P, K, L, and Q. The front, any combination of K, L, N, and M. Then the back, P, Q, R, S. The left side, P, K, N, S. And the right side, Q, R, M. So any combination of those. All right? And in any order. So you want to put N, K, P? You can for this one. All right. So here we're going to get a little bit more specific. Now that we know what point, line, and planes are, we can get more specific to see which now we know what those are, we can get more specific in terms of a line segment, array, and opposite rays. So here we have a segment. A segment is when we chop off a line, okay? So it looks like this. It looks like segment AB. Let's rewrite it because it's a little hard to see that one. It doesn't have arrows, and the hat stands for its name. So it's segment AB, and we can also write it as segment AB, which you see here. I do prefer the segment above AB, but you can also write it segment AB. It has endpoints A and B. We can also name it segment BA. That's allowed as well. Because remember, what is a line? A line is an endless amount of points that lie in opposite directions from one single given point. So it looks like this, and it goes on forever. Chop it off, and what do you have? You have a line segment. Well, you still, guess what? Have an endless, even though it's fixed and it doesn't go on forever, there's an endless amount of points in between these points, right? And you can hear my pencil probably furiously filling in this gap, and it's because it's endless, all right? We have endless amounts. So because they're endless, it actually, see, it says it right here. A segment is the part of a line consisting of two endpoints with all points between them, endless points between them. Okay. So let's take a look at this next one. Array has an endless amount of points, but it starts somewhere at what's called an endpoint. So this one has two endpoints, segment has two, but this one is an endpoint, and it goes on forever in the direction of another point and keeps going on and on and on forever. Well, this one, I want you to put a note here, and students are going to mess this up. I'm going to say it 1,000 times. Someone is going to mess up. It's okay. We're going to learn from it. But here's what's most important. We're going to put order matters. Order matters for array. Order matters in array. Only in array do we really have to be cautious on how we refer to it. Let's look at the four options we have. We could say XY. We can say YX. We can say XY this way. And we can say YX. YX. And you were hoping that I said, oh, you can use any four of those combinations. No, get a red pen right now, or whatever you have, and cross out a couple of them. You know what we can't do? We can't do these because those go in the wrong direction. Your array always has to go, when you write it, when you handwrite the name, you always have to go from left to right. It's not an option. Not an option, okay? The ray itself, this ray in space, can be in any direction. It can go up, it can go down, it can go left, it can go right. Doesn't matter. But when you handwrite its name, when you're naming it, it has to go left to right. And it always has to start at an end point. It always has to start at an end point. I'm sorry if you can hear my neighbors yelling. This is what happens when you make a video. So it always has to start at an endpoint. So in this case, the endpoint is Y. So Y is the first letter that we're going to use. So I don't want to get too complicated here with the colors, but yeah, let me do this. That's what you're going to start with. So the answer to this is No, you cannot do any of those. The only one you're allowed to do is YX and write it from left to right. I know the ray is pointing in the opposite direction. It does not matter the way it points because rays can go anywhere. Rays can go up, down, across. They can go this way. It can go this way. Think about a sun. Think about all the rays of a sun. It doesn't matter. You always start at its endpoint, Y, and go in the direction of X. And you can read it off to yourself. Say, okay, Mr. A, start at Y, go in the direction of X. And there you go. All right. So a ray is part of a line segment consisting a line containing one endpoint and all points that lie on one side of that endpoint. And opposite rays, they have to be collinear. Just give that a highlight. They have to be collinear. That means that they have to lie in the same line for them to be considered a line. They have to be on the same line for that. Sorry, this is not the setting I want. They have to be on the same line for them to be considered a opposite rays, a pair of opposite rays. Okay, they always form a line, and they share the same endpoint. So here's what is not an opposite ray. These are not opposite because not opposite because they do not they are not collinear. Here is what is also not opposite rays. I know it's hard for you to see what I just did. AB and BA are not opposite. You know what? I'm so sorry. I want to make sure it's on the same page. Why? Because they overlap. They cannot overlap. They have to have the same endpoint. Okay? So because AB and BA overlap on the portion of that AB, those are not opposite rays. Okay? They just can't overlap. In this case, R is an endpoint. It goes from R to S and it goes from R to Q. All good. No overlapping. Okay? I like to look, if I see 3 letters, I can have opposite rays. If I only have 2 letters, I can't have opposite rays. I need 3 because I need to identify a brand new location like R that A can go in the direction of as A goes in the direction of B as well. So AB and AR, those are opposite rays. Okay. So that's pretty much all of our vocab for the lesson. So let's, we might get a little bit more, but let's do this. Name the segments and rays in this figure. So take a second, try to answer this, pause the video, and then you can come back. And I'm going to answer it right about now. Okay. Segment LP, segment PQ. Don't forget segment LQ. It can be all the way from here to here. That's a segment. Okay. We can also write the flip of it. PL, QP, and QL. Now, these are not unique, but they are rays. They are repeated rays, okay? Segments. Let's do rays now. We have ray PL. We have ray PQ. We have ray QL. We have ray LQ. We have ray, okay, so I got PL. I got PQ. I got QL. I got LQ. Let's see, wait, I got LP, LQ. Oh, no, I don't have LP. The last one is LP. and QP. Now, I'm going to write the repeated rays. So here are the same rays. QP is the same ray as QL. Even though they don't look it, they start at Q and they go in the direction of P, but they also go in the direction of L. So these are the same rays. Those are the same. What else is the same? Well, LP, and LQ are also the same ray. Because as you go LP, you also go LQ, you overlap P and Q, so it doesn't matter. As long as the endpoint is L for both of those are the same ray. And here is another thing, PL and PQ, these are not the same, they are actually opposite rays. Because PQ goes this way and PL goes this way. They share a common endpoint and they are collinear. So endpoint and they are, endpoint and they are collinear, therefore they are opposite. Okay? Again, the sun's rays, they go in all different directions. Pretty cool. I just felt like including that picture there. LP and PL form a line. Are they opposite? Well, let's take a look. LP and PL. Let's look at LP and let's look at PL. Are they the same? Are they the opposite rays? And the answer is, wait for it. Not opposite, because look at how much overlaps. So the answer is going to be no, because they overlap. Because really the answer is no, because they do not share an endpoint. Give me a second, I'm sorry. They do not share an endpoint. And we can even say they overlap. And we don't want that. Okay? All right. Recognizing parallel. So take a look at here. Ooh, look at this. Skew. That is our vocabulary word we were looking for earlier today. So what is skew? Well, take a look. Here, think about this like a tissue box. The front box is parallel. The top and the bottom of the front of the box of tissues is parallel. They do not intersect. Here, the bottom and the side intersect, and the bottom and the side intersect. The top and the side intersect, and the top and the side. Those are intersecting. These are parallel. But what happens when it's parallel? But then I take the back here, and it's not parallel, but they also don't intersect. CG will not intersect with AB or EF, but they will get farther apart because AB is staying here. CG is going on and on here, so their distance starts to get really, really far apart. That's what we call skew. They do not intersect, but they also are non-coplanar. So take a look. A, B, E, F are coplanar. They're on the front plane. CG is on a different plane. Let me use different colors. Here's the front plane. Here's the side plane. I keep doing something wrong here. My bad. Okay. Therefore, they are what we call skew. So they'll get further and further apart and they'll never intersect. So I'm going to go right back to the beginning. I'm going to work, I'm going to write real quick, no skew. The answer here is no, they are skew. All right. And so that's what skew is. So here's a way of saying that they're parallel. This symbol right here, that's our, the pencil, hold on. Yep. Why is it doing that? That's weird. Give me a sec. So whenever I partially disconnect from the iPad, okay. That means, whoops, that means parallel. And obviously this word means skew. So we can say that AB is parallel to EF, or BA is parallel to FE, or whatever we want to say. But then we'll also say that AB and CG are skew. And we can also say EF and CG are skew. Okay? Which I think they say later on here. Okay? Parallel planes, we can say the same thing about parallel planes. We have two planes that are parallel, A, B, C, D, being the front plane and the back plane. If you're having trouble seeing the back plane, see these dotted lines? Those represent the behind the scenes of what's happening. So that's like the back end of your tissue box, the reverse side of your tissue box. So here we have that the front plane and the back plane are parallel. The top and the bottom are parallel. The left and right are also parallel. Notice they also have that GH, which is part of plane, which is part of this plane. GH alone, the line GH, is also parallel, right? So your front plane is here. Your line back there is parallel as well. It will not intersect the plane. And here's just some notation that you can use when you write them. All right. So let's name all segments that are parallel to DC. Here's DC. It's kind of hard to see, but here's DC. So what's parallel? Well, it looks like AB is parallel. It looks like GH is parallel, and it looks like JI. It's really hard to see that, but it looks like JI is also parallel. So here are the parallel, those four are parallel. N does not follow, N does not have anything to match with, so don't worry about that N that you see there, okay? So these are segments. So I'm going to say AB, so segment AB. So let me write it this way. Segment DC is parallel to AB, is parallel to GH, is parallel to JI. All those segments. Okay? What is skew to DC? Well, skew, let's take a look. DC, skew. Looks like CH intersects it. Looks like DG intersects it. Looks like JI is parallel. Looks like GH is parallel. Looks like AB is parallel. So that really narrows down what I can work with when I'm talking about DC, which is this right here. You know what? It looks like what will not what won't intersect is HI. HI is good. HI is skew. Can we get creative? And some of you are going to say, hey, Mr. A, what about, oh, wait, you know what? GJ as well. GJ is skew. GJ and HI are skew. our skew to DC. Can we get creative? Can we say like NG is NG is 1? Yeah, maybe. That looks like it's running on a diagonal. You have your rectangular, you have like this rectangular side, and yeah, it can be on a diagonal and it would still work, but let's not get too complicated, okay? Parallel to GJ. Let's see, GJ. Here's GJ. What's parallel to it? Looks like ND and HI. So ND and HI. What about GJ? Well, wait a minute. I'm sorry. GJ. Okay, parallel. I'm sorry. What's skew to GJ? So let's see. Those are parallel, so we can't use those. These intersect. Oh wait, GJ. Oh, not that one. These intersect with it. So what is skew? It's actually going to be AB. It's going to be AB. It's going to be DC and CH. Okay. Yeah, so you have this one, and this one when talking about GJ. The other ones intersect or are parallel to it. So the ones in blue are parallel or intersect with this one. With this one. The other ones are good. Okay? All right, there's a lot of writing. I'm sorry. I have the ability of writing, erasing, writing, erasing. You all don't really have that ability. Name another pair of parallel segments of skew segments. You know what? We Let's move on. I think we answered this. Look above. Okay, I really want you to just kind of make this one up, but I think we did plenty of work on this. Okay? All right, identifying parallel planes. Use the diagram at the right to name the figures. So two pairs of parallel planes. Let's see. Doesn't really matter. Let's do the left side of the box. So let's say plane A, D, J, G, and plane B, H, I, C. And let's name a line now that is parallel to plane GHIJ. So GHIJ is the back plane, okay? So let's name a line that's parallel. Let's get crazy and let's go a diagonal. Why not? Let's say AC. AC is a diagonal, but it's parallel because ADBC is in the front. So we're going to say line AC is parallel to GHIJ. All right. It could have been any combination of those letters. So A, B, C, and D, you could have used any one of those combinations for that line. All right. Use the diagram at the right to name the figures. So three pairs of parallel planes. Oh, okay, three pairs. All right, all right. I didn't answer the first question correctly. I did, but I didn't answer it fully. So here's one pair of parallel planes. Here's the second pair. Let's do the left side and the right side. So I'm going to say plane A, G, J. Oh, wait. I'm sorry. What did I do? I did initially the left and right side. So I'm going to do the top and bottom. So AGHB or AGH and DJI. So that is my second pair of planes. Remember, a pair is two, and I wanted two pairs, meaning that I have four items that I'm listing. So this last one is three pairs of planes. Oh boy, this one, all right, this is everything we got. So one, I'll say plane SPR and plane SPR and plane WTU. The second one will be plane PTU and plane PTU and SWV. So that was the front and back. The first one was the top and bottom, and now I need the left and right. So SPT and plane QRU. All right. Name a line that is parallel to plane QRUV. QRUV is the right side. So anything on the left side. So I'll just say line, line. Oh, you know what? I'm going to use the line notation. Line SP. Why not? That's just one of them. Again, you could have used SP, T, and W, and any combination of those. All right, I think that's good. I think I did. I think I did an extensive job at explaining that. If you have any questions, let me know. And you are ready to begin this homework and complete the IXL assignments in class tomorrow. All right. Good luck.